NEC 2002, Table B, 310.6 provides ampacities for conductors and raceways with multiple electrical ducts. The maximum number of ducts considered in the table is 6. In NEC 2005, Table B, 310.6 was revised to include ampacities for conductors and raceways with up to 9 electrical ducts. The ampacity adjustment factors are as follows for the number of electrical ducts. For 1 duct, the ampacity adjustment factor is 1.0. For 2 ducts, the ampacity adjustment factor is 0.80. For 3 ducts, the ampacity adjustment factor is 0.70. For 4 ducts, the ampacity adjustment factor is 0.60. For 5 ducts, the ampacity adjustment factor is 0.55. For 6 ducts, the ampacity adjustment factor is 0.50. For 7 ducts, the ampacity adjustment factor is 0.47. For 8 ducts, the ampacity adjustment factor is 0.45. For 9 ducts, the ampacity adjustment factor is 0.43. The main difference between NEC 2002 and NEC 2005 is that NEC 2005 provides ampacities for conductors and raceways with up to 9 electrical ducts, while NEC 2002 only provides ampacities for up to 6 electrical ducts. This has implications for electrical installations. For electrical installations designed according to NEC 2002, the ampacity adjustment factor for raceways with more than 6 electrical ducts must be determined by interpolation. For example, the ampacity adjustment factor for a raceway with 7 electrical ducts would be interpolated as follows. The ampacity adjustment factor for 7 electrical ducts equals 0.47 plus 0.50 minus 0.47 multiplied by 7 minus 6 divided by a minus 6, which equals 0.485. For electrical installations designed according to NEC 2005, the ampacity adjustment factor for raceways with up to 9 electrical ducts can be obtained directly from Table B, 310.6. Ampacity refers to the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. It's a critical factor in electrical design to prevent overheating and potential hazards. The National Electrical Code, or NEC, provides tables and guidelines for determining the appropriate ampacity for different types of conductors and installation conditions. When multiple conductors are installed in close proximity, such as in a raceway with multiple electrical ducts, the heat generated by each conductor could affect the temperature of the others. This requires adjusting the ampacity to account for the increased ambient temperature. This adjustment is done using ampacity adjustment factors. These factors reduce the allowable ampacity of the conductors to ensure they don't overheat. The specific adjustment factors depend on the number of conductors, the type of insulation, and the ambient temperature. The NEC provides tables with these factors for various scenarios. Interpolation is a method used to estimate values that fall between known data points. In the context of ampacity adjustment factors, if a table only provides factors for specific numbers of conductors or ducts, interpolation can be used to estimate the factor for an intermediate number. For example, if a table provides factors for 6 and 8 ducts, interpolation can be used to estimate the factor for 7 ducts. The formula for linear interpolation is as follows. Y equals y1 plus it1 minus y1 multiplied by x minus n divided by x2 minus n, where y is the value to be estimated. y1 and it1 are the known values, x is the point for which you want to estimate the value, and n and x2 are the corresponding points for the known values. In the example provided, the ampacity adjustment factor for 7 electrical ducts is calculated using interpolation. The known values are the factors for 6 and 8 ducts, which are 0.50 and 0.47 respectively. The interpolation formula is used to estimate the factor for 7 ducts, resulting in a value of 0.485. The NEC is updated periodically to reflect changes in technology, industry practices, and safety standards. Different editions of the NEC may have different requirements for ampacity adjustment factors. Therefore, it's important to refer to the correct edition of the NEC when designing electrical installations. The NEC 2005 edition expanded the ampacity adjustment factors to include raceways with up to 9 electrical ducts, providing more comprehensive guidance for electrical designers. This eliminated the need for interpolation in many cases. The ampacity adjustment factors in Table B, 310.6 of the NEC are based on specific assumptions about the installation conditions, such as the ambient temperature and the type of raceway. If the actual installation conditions differ significantly from these assumptions, additional adjustments may be necessary. For example, if the ambient temperature is higher than the value assumed in the table, the ampacity of the conductors must be further reduced. Similarly, if the raceway is installed in direct sunlight or in a poorly ventilated area, additional adjustments may be required. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect conductors from overloads and short circuits. These devices are designed to interrupt the flow of current if it exceeds the ampacity of the conductors. The ampacity of the conductors must be carefully coordinated with the rating of the overcurrent protection devices to ensure proper protection. The overcurrent protection devices must be sized to protect the conductors without causing nuisance tripper. When selecting conductors for an electrical installation, it's important to consider not only the ampacity requirements but also other factors such as the voltage drop, the type of insulation, and the environmental conditions. The voltage drop is the reduction in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of the electrical system. The type of insulation must be suitable for the operating temperature and environmental conditions. The environmental conditions may include exposure to moisture, chemicals, or ultraviolet radiation. In addition to the ampacity adjustment factors in Table B, 310.6, the NEC also provides ampacity correction factors for ambient temperatures other than 30 degrees Celsius, which is 86 degrees Fahrenheit. These correction factors are used to adjust the ampacity of conductors when the ambient temperature is higher or lower than 30 degrees Celsius. The correction factors are typically expressed as a percentage of the ampacity at 30 degrees Celsius. For example, if the ambient temperature is 40 degrees Celsius, the ampacity of the conductors may need to be reduced by 10%. The NEC also provides guidance on the derating of conductors in specific applications, such as when they are installed in cable trays or in underground ducts. Derating refers to the reduction in ampacity that is required to account for the specific installation conditions. The derating factors may be specified in the NEC or may need to be determined based on engineering calculations. When designing electrical installations, it's important to consult the latest edition of the NEC and to follow all applicable codes and standards. The NEC is a comprehensive document that provides detailed guidance on all aspects of electrical safety. It's essential for electrical engineers, contractors, and inspectors to be familiar with the NEC and to apply it correctly. The information provided in Table B, 310.6 of the NEC is based on specific assumptions about the type of conductors, the type of raceway, and the installation conditions. If these assumptions are not met, the ampacity adjustment factors may need to be modified. For example, if the conductors are installed in a non-metallic raceway, the ampacity adjustment factors may be different than if they are installed in a metallic raceway. Similarly, if the conductors are exposed to direct sunlight, the ampacity adjustment factors may need to be adjusted to account for the increased heating effect. The NEC also provides guidance on the installation of conductors in parallel. When conductors are installed in parallel, the ampacity of each conductor must be derated to account for the increased heating effect. The derating factors for parallel conductors depend on the number of conductors in parallel and the spacing between the conductors. It's important to follow the NEC guidelines for the installation of parallel conductors to ensure that the conductors are properly protected and that the electrical system operates safely. The ampacity of conductors is also affected by the frequency of the current. At higher frequencies, the current tends to flow closer to the surface of the conductor, which increases the resistance and reduces the ampacity. The NEC provides guidance on the ampacity of conductors at different frequencies. It's important to consider the frequency of the current when selecting conductors for high-frequency applications. The NEC is not a substitute for engineering judgment. It's important to use sound engineering principles and practices when designing electrical installations. The NEC provides a framework for electrical safety, but it's up to the engineer to apply the code correctly and to ensure that the electrical system is safe and reliable. The information provided in Table B 310.6 of the NEC is based on empirical data and engineering calculations. The ampacity adjustment factors are designed to ensure that conductors do not exceed their temperature rating under normal operating conditions. However, it's important to note that the actual temperature of the conductors may vary depending on the specific installation conditions. Therefore, it's important to monitor the temperature of the conductors and to take corrective action if necessary. The NEC is a living document that is constantly being updated to reflect changes in technology and industry practices. It's important to stay up to date on the latest edition of the NEC and to be aware of any changes that may affect the design and installation of electrical systems. The NEC is an essential tool for electrical engineers, contractors, and inspectors. It provides a comprehensive framework for electrical safety and helps to ensure that electrical systems are designed and installed in a safe and reliable manner. Understanding the differences between different editions of the NEC, such as the 2002 and 2005 editions, is crucial for ensuring compliance and safety in electrical installations. The expansion of Table B 310.6 in the 2005 edition to include ampacity adjustment factors for up to 9 electrical ducts simplified the design process and eliminated the need for interpolation in many cases. This highlights the importance of staying informed about the latest revisions to the NEC and their implications for electrical design and installation. In summary, the differences between NEC 2002 and NEC 2005 regarding Table B 310.6 are significant for electrical design and installation. NEC 2005 expanded the table to include ampacity adjustment factors for up to 9 electrical ducts, while NEC 2002 only covered up to 6 ducts. This change simplifies calculations and provides more comprehensive guidance for electrical professionals.